Hello everyone. In this video we will talk about security concerns in the wireless LANs. Till now we have seen physical layer and MAC layer of a wireless LAN. Now one of the optional function of MAC layer is providing security during a data transmission. Now there are several types of security like authentication or encryption that can be provided for a data transmission. So we will see in detail about that one. So we all agree that security is a more of a concern in wireless. But why it is more of a concern in wireless compared to the wired networks? The first and foremost reason is the physical medium is absent in wireless communication. So there is no inherent physical protection. There are no wires, there are no cables. So when the data is getting transmitted, it is not protected from environmental effects via wires. So they are transmitting through radio waves and they are open to air. So any environmental factor can easily impact the data transmission. Okay, so these physical connections are replaced by logical associations in case of wireless, that is by means of the radio waves, and which are susceptible to the environmental factors. Now, second reason is that in wireless the communication is basically broadcast in nature. That means whatever data you send can be received by everyone within the vicinity of the sender. Wireless usually means a radio. Radio means radio waves which are having a high frequency. It is having a broadcast nature. Transmissions can be overheard by anyone in the range. Okay, so if we are not using any encryption or security, then if it is transmitted in its original format, everyone can read your messages, and that is not desirable in case of unicast communication. Okay, so anyone can generate transmission, anyone can pretend to be you and send a message to actual receiver. So that is a kind of a attack that is observed severely in the wireless networks. So it is possible that you will interfere other communication as well. Just like others can interfere in your communication, unintentionally you can also interfere into the others communication, because your transmission will be received by everyone in the range. So if they are already communicating, then it will be an interference for them. So that is called as a jamming. So that is also another issue in the wireless network which we don't see in the wired networks. Then eavesdropping is very easy in case of wireless, because there is an absence of physical connection between sender and receiver. Eavesdropping is nothing but secretly listening to the actual ongoing communication. Then injecting bogus messages into the network is also easy. So this is nothing but, if we want to uh, hijack the communication or waste the bandwidth of communication so that desired operation is not carried out, then you can, as an attacker, you can inject a bogus messages into the network. This is another type of attack which we several times see in the wireless networks. So injecting fake messages into the network is easy, so that bandwidth is occupied and it can provide a denial of service attack, DOS attack. Okay, so if bandwidth is occupied all the time, others cannot exactly acquire the bandwidth for communication. Then replaying previously recorded messages is also easy. That means if you want to hijack the communication, you can hijack the identity of a user and replay the same message again and again, so that bandwidth is remained occupied and further communication is not possible. This is called as a replay attack. All the types of threats in this wireless LAN we will see at the end of this entire discussion regarding security. Then illegitimate access to the network and its services is very easy. So any fake user can access the network without, if the network is without any kind of security, the fake users can easily access the network. So illegitimate access is easy in case of wireless LAN. That's what the last one, denial of service, is easily achieved by jamming also. Okay, so jamming prevents other users from accessing the network, and it is again a type of a denial of service. Okay, so then apart from these usual threats that we see in the network, there are some additional issues. First one is a mobility of a user. Now, since users are supposed to be mobile in the wireless media, especially in the mobile network, uh, they are carrying the portable devices, so they can easily be stolen by the attackers. So they are not physically secure. So if they are stolen, they can send messages using your device and carry out the communication on your behalf. Okay, so that is also a threat in case of wireless network. If you intend to use a security in your communication, then you might employ a complex security algorithm which is used in the wired networks, but those security algorithms will consume so many resources like memory and processing resources that battery will drain out quite easily. So you have to think of a security which will be power conservative. So need a simpler security in case of wireless compared to the wired networks. So keeping in mind all these requirements, uh, there are few factors which were considered as a mandatory or minimum required security concerns or security essentials by the wireless LAN, and these are generally classified broadly into 6 types. First, the wireless communication should be confidential. So confidentiality is the first requirement of the security in the wireless network. So confidentiality is nothing but the messages exchanged over the wireless network must be encrypted so that only intended participants of the communication will be able to understand them. Apart from those intended participants, nobody else should be able to understand what the communication is going on. So others may receive your messages, but they will not understand the meaning of those messages. That is the meaning of confidentiality. Then authenticity. This is nothing but verifying whether the sender of the message or origin of a message is a verified or not. Okay, so authenticated user is has sent this message or a fake user has sent this message, that must be checked. And the third requirement is replay detection. So if you are receiving same message again and again, you should not waste a time on decrypting or uh, processing the same received message again and again. So detecting freshness of a message, sorry, detecting freshness of a message is another essential thing regarding security in the wireless networks. Then fourth one is integrity of the received message. So whatever message that you have received, you have to check whether the same message was transmitted by the transmitter or not. So that is required because messages over the wireless media, that is in the free space, can be modified. That can happen in case of wired network also, although in case of wireless network it is not that easy, but it is still possible. So you have to check whether man in the middle attack has happened or not. If somebody in between has hijacked your communication and modified the contents of your intended received message, then you should check that one. So checking the integrity of message is another important aspect. And fifth one is a authentication related, that is access control. The network should be accessed by only the legitimate entities. Okay, if a network is supposed to provide services to 5 users, all the 5 users should be valid or authenticated users. There should not be any intruder or attacker inside the network. Okay, and apart from that, that access given should be permanent one. So it's not just to check the legitimacy of the entity when it joins the network, but throughout the presence of that particular entity within the network, that access should be, or that integrity should be checked, or authenticity should be checked, because logical association can be hijacked easily. So it's not like that once you join the network, uh, it will remain as it is throughout your existence in the network. You have to verify your authenticity or uh, validity throughout the existence of your network, in your network. Okay, so from time to time you will be required to authenticate yourself. That time may be different for different networks, so networks will decide how much time it will refresh the authentication process. Then the last one that is very essential is a protection against jamming. Other communications should not hamper the ongoing communication, so protection against the jamming is also necessary. So considering all these security requirements, IEEE 802.11 introduced first security standard in wireless LAN for the first time in IEEE 802.11b. We have seen standard of 802.11b in the last video. In that you have seen that security is provided by a WEP protocol. So we are going to see this WEP protocol which was introduced in 802.11b. That is was the first standard. So before going to understand the working of WEP, first we should understand the process of how infrastructure based networks operate for communication. So most of the time these infrastructure networks are nothing but called as Wi-Fi. Okay, so let's see the Wi-Fi operation, how communication happens in the Wi-Fi. So let's say a station enters into a infrastructure based network. Let's call it now as a Wi-Fi network. So which has a access point. These access points, there may be more than one access point. Here in this diagram only shown as one, but there may be another one also. So these access point continuously they are sending a beacon message with their own SSID, that is service set ID, and a security level that they are providing. Now once you enter the network, you will receive this beacon frame or beacon message and decide which access point to choose from. So subscriber station listen to these beacons, measure the signal strength, who is providing a better signal strength, and determine which access point to join. Once they determine, let's say this access point is providing a better signal strength, so this station wants to join this network. It will try to authenticate itself with this access point. Subscriber can also send a probe message to find access points in the neighborhood. So why these probe messages are required? Let's suppose that once a station enters a network, it does not receive any beacon message. So what will happen now? If it does not receive the beacon message, it can send a probe message to find out which are the access point there are in the vicinity of that particular station. So probe message is as an alternative to the beacon messages. So once it has decided that one particular access point is providing a rather better service, it tries to authenticate itself with that particular access point. Okay, access point authenticates the subscriber using shared keys. Okay, that is shared key, pre-shared key authentication. Okay, that process we will see later on. Once they are authenticated, subscriber and access point exchange the encrypted packets. Okay, once the communication is over, then disassociate message is sent to the access point and station is logged off from the access point. Okay, so there are two types of authentication which we can see in the infrastructure networks, that is Wi-Fi. First one is open system authentication and second is shared key authentication. So open system authentication does not include any kind of password. Once you enter a network and decide which access point to join, you can simply enter the SSID of that access point and you will join the network. No verification will be done, no keys will be shared. Okay, so it is an open access Wi-Fi network. Okay, anyone can join. And then shared key authentication means it is based on challenge response method, where you will be required to enter a password which will be nothing but a response to a challenge offered by the access point. most of the security is provided. This is not so secure. Open system authentication does not provide security, so shared key authentication is used mostly in all the Wi-Fi networks or wireless LAN networks. So as we have talked about, let's talk about the WEP protocol. WEP stands for Wired Equivalent Privacy. So this protocol, which was introduced, supposed to provide uh, a privacy which was equivalent to the privacy offered by the wired networks. Whether they achieved it or not, that is a different issue or different point of discussion. But because based on that, the name was given as wired equivalent privacy. So data security using encryption is a, as I said, optional function of the MAC layer. This function is known as a WEP in case of 802.11. Now one important thing to note here is this encryption is only supplied between stations and not on end-to-end basis. So if there is a transmitter and there is a receiver, so there will be access point in between. So the encryption will remain valid only between stations, transmitter to access point and access point to receiver. So this encryption is different from this encryption. Same encryption mechanism will not be used. Both will be WEP, but uh, the encryption keys will be different for different connections. Or in case of ad hoc network also, if the communication is multi-hop, there will be intermediate node. So direct is encryption is not provided. Only link based or hop based encryption will be provided. Okay, so key management, how to manage the different keys is not specified, that is left up to the access points. Authentication is performed by assigning extended service set ID to each access point. So in a one Wi-Fi network, there may be several extended service IDs which are connected by the distributed systems or distribution systems. So ESS ID is provided to each access point so that they will know to which ESS set, that is extended service set, they belong, and using this ESS ID, authentication can be done via challenge response method. Uh, this WEP is a part of a 802.11 specification, so it's a standard and a mandatory one for all the versions onwards of 802.11b. So that you can see defined in 802.11b. So whichever standard which was developed after the 802.11b has to provide at least WEP level of security. Later on, further security mechanisms were introduced like WPA, WPA2 and so on, but at least WEP should be provided. Okay, so what WEP provides? It provides both authentication as well as encryption. We will see both one by one. So WEP is the first security mechanism introduced in the wireless LAN by IEEE 802.11. So let's see the authentication process. Sorry. Authentication in WEP is via challenge response method, and it is using a shared secret key. So it's a shared key authentication. It's not a open system authentication. It's a shared key authentication. So authentication is based on simple challenge response protocol, where when a station enters into the network, it sends a authentication request to the access point. Now access point sends a challenge to the station, to which station responds with a response. Now this response is calculated by using the shared secret key which are available with both access point as well as station. Now how access point and station are sharing the secret key, that is not defined in the IEEE 802.11 standard or WEP standard. WEP does not define how secret keys are shared between access point and station. So using that secret key, station will calculate the response and send it to the access point. Okay, now access point will check whether the challenge and response is matched or not. If it is matched, it tells the station that authentication is success. If challenge and response do not match, it tells the station that authentication is failed, so the station cannot be connected. Okay, so this is simply nothing but entering the password for the Wi-Fi network and getting successfully connected. So once authenticated, station can send an association request that is sent in by default once the password is successfully accepted, and access point will respond with the association response. That's the message that we see after correcting the correct password, that is connected. That message we will see when we enter the correct password. Okay, if authentication fails, no association possible. Okay, so we can see the corresponding message also, that password is incorrect or something like that. So that is the association and disassociation, or rather than association and not being able to perform association. Okay, so that is how authentication is carried out. So key part is challenge and response, that is access point sending a challenge and station calculating a response using a shared secret key. Now that is the important part of this authentication process. And how the keys are exchanged, that is not mentioned over in the standard. So after authentication, the next security level is providing encryption, that is providing confidentiality for the communication. So the encryption mechanism is shown on your screen, where different new things you will see. We will see them one by one. So WEP encryption is based on a RC4 stream cipher. You might have studied this RC4 stream cipher in another subjects like network security or system security. Okay, RC4 stands for Ron's reversed cipher number 4, because it uses 4 different keys for encryption. So that is used in case of WEP encryption. So we'll see how it works one by one. So in WEP, every packet that is transmitted is using a separate key. So the per packet encryption key is different. Okay, now how that is generated? Now that is generated using 24-bit initialization vector, that is IV, 24-bit initialization vector, and one of the pre-shared keys. RC4 requires 4 keys or provides 4 keys. Out of these 4 keys, one key is used for generating per packet encryption key. This key will change, okay, from packet to packet. Now how that will change? Let's see the process. Now for that, before seeing the process, for this encryption algorithm, RC4 key is either 64-bit or 128-bit, out of which 24 bits are initialization vector, that is seen over here, and remaining bits are secret key, one of the pre-shared key. So original standard provided 64-bit key, which was later on enhanced to 128-bit key. Okay, so let's see how the encryption happens. Now, as I said, IV is appended, that is concatenated. This particular symbol is nothing but concatenation. So simple appending of a IV plus pre-shared key. Okay, so combination of these, that is done to produce a seed. Now this seed, that is nothing but a sequence of ones and zeros, is provided to pseudo random number generator. PRNG stands for pseudo random number generator, so which takes the input as a seed, which is nothing but combination of these two. Now based on each seed value, a different random number which will be generated as a RC4 key sequence. Okay, RC4 key sequence is generated for each RC4 key. For each RC4 key, a new key sequence will be generated by the pseudo-random number generator. Now this key sequence is used for encryption. Now the data that has to be encrypted, that is your plain text. That data must be checked for integrity also. So to provide an integrity of data over a wireless link, it is applied to an integrity algorithm, which is nothing but a CRC32. 32-bit CRC is calculated for a given data, and that is used as a ICV. So ICV is nothing but CRC of a data to be transmitted. So ICV stands for integrity check value. Now your data, that is plain text plus CRC value, is used for encryption. Okay, again there is a concatenation, simple appending of the plain text. At the tail end, CRC is appended. CRC is called calculated on the plain text. Now using the key sequence and this now plain text plus ICV, a cipher text is generated. So important thing is cipher text is equal to key sequence XOR with plain text plus ICV. Okay, so this is a very important thing. We will show that cipher text is nothing but key sequence XOR with plain text and ICV together. Okay, so at a reception, what will happen? We will receive a cipher text. From that, we have to recover a plain text. So exactly reverse procedure can be carried out. So in order to recover plain text or ICV, plain text ICV, that is a combination that is obtained via XORing cipher text with the key sequence, that is at the receiver. Okay, so that is important to remember. So remember this thing at receiver. That's why XOR operation is done, because it is linear in nature. At the receiver, it should be easy to recover original plain text from the received cipher text. Okay, so the data that is transmitted is not only the cipher text. Initialization vector is also sent along the cipher text, which is appended previous to the cipher text. So the data that is transmitted, so transmission is of a IV along with the cipher text. This packet is transmitted as a data packet. Okay, so this is how encryption is carried out. So operation is mentioned over here. Steps are mentioned. For each message to be sent, RC4 is initialized with a shared secret between RC4 produces a random number that is known as a key sequence. This pseudo random byte sequence is XORed to the message. It is essential that each message is encrypted with a different key stream. So important thing is this key sequence should be different for, this is different for different packet. Okay, IV is same, sorry, IV is also different. Shared key is same for each packet, same for each packet. Shared key is same for each packet. This is important to remember. Okay, so each message is encrypted with a different key stream. Shared secret is same for each message, but that this is for keeping identifying the user. Okay, IV changes for every message and initialization vector will change for every message. That's why it is sent along with the cipher text. WEP integrity protection is based on the encrypted CRC value. ICV, which is nothing but a CRC of a plain text, is appended to the message, and message and the ICV are encrypted together. Process we have already seen. So at the receiver end, what happens is the exactly opposite process of the transmission. So at the receiver end, simple, what we receive is a this thing, IV plus cipher text is a received value, out of which cipher text is extracted separately and IV is extracted separately. Now shared secret key between station and access point, that is used for extracting the plain text. We know that this key is available with the station as well as access point. So this secret key is appended to the received message. So secret key is appended with the received message, that is IV plus cipher text. Okay, and given as a seed to pseudo random number generator. So this becomes a seed for pseudo random number generator. That generates a key sequence. Now this key sequence will be used for separating a plain text from the ciphertext. So what happens? Key sequence is XORed with the ciphertext. Now this we have studied just. If key sequence is XORed with a ciphertext, what we get? Plain text and ICV. Sorry. We get plain text and ICV. Okay, key sequence XORed with ciphertext gives you plain text and ICV. So plain text is separated and ICV is separated. Now integrity of the received plain text should be also checked. So this plain text is given to integrity algorithm. Another ICV is calculated. This ICV, that is known as now ICV dash. So calculated ICV is it equal to received ICV? That is checked. If both are same, then there is no alteration of a transmitted text. The correct text has been received. And this is how integrity is verified. Okay, integrity is verified, decryption is done verified correctly, and this is how WEP provides the security. But although it seems a decent amount of level of a security provided by WEP, there are several flaws in this particular mechanism. So first we will see the flaws related to authentication method and access control. Now first flaw is a authentication is a one way only. That means access point verifies authentication of a user, but user doesn't know whether access point is a valid one or not. So that is one way authentication. Station may associate to rogue AP. Okay. Then same shared secret key is used for authentication and encryption. So whether it is authentication or encryption, same key is used. Let's say K1, K1. So weakness in any one of the protocol. If authentication protocol is weak or encryption protocol is weak, then you can easily identify key and you can easily hijack the communication. Okay, so that's why different keys are desirable for different functions. Third, no session key is established during authentication. Okay, once authenticated, it remains continuous. It is not continuous. Okay, so it remains continuous, but access control is not continuous. That means what? Once you get connected, then it will not expire. Your authentication will not expire unless you go out of the network. Once station has authenticated and associated to access point, attacker send messages using the MAC address of station. That is, if attacker manages to intrude your MAC address, it can easily authenticate itself with the access point and send the messages. So correctly encrypted messages may not be produced by the attacker, but replay of station messages is still possible. So that is how users usually provide the replay attack, or intruders usually do the replay attack. They hijack your MAC address, get authenticated to the access point, and keep on sending the same message again and again, thereby consuming bandwidth of a access point. Then apart from this, station can also be impersonated. So let's recall authentication process where R is a challenge sent by the access point and station calculates a response to that. So how does station calculate a response to that? It by XORing a secret key. K is a secret key. K is a secret key which is used for calculation of response. So this is secret key. Now XOR operation is linear one. So if R is given and you have to calculate a response, R that is calculated via this thing. If intruder sees this, intruder will also capture this R which is sent by the access point and further XOR whatever sent by the station. So in the first authentication step, if R is further XORed, you will get a key. So an attacker can compute a key and use that key to impersonate station later. So using this key, further communication, that is after the authentication, can be impersonated or can be hijacked by the attacker. and that is a weak nature of the XOR operation. Okay, that is because weak nature of the XOR operation. Then this is regarding the flaws in the authentication and access control. Now let's see what are the flaws in the encryption and integrity protection. Okay, so WEP does not provide any protection for replay. We saw initialization vector is changed, but it is of only 24-bit. So it is not mandatory to increment after each message. So same initialization vector may be sent from time to time, and which happens in most of the cases because IV value is too short. It is of 24-bit. So only there are 2 raised to 24 possible IVs. So if data is large enough, there is every possibility that this IV is repeated from time to time, and that is not desirable because it becomes easier to hijack communication if IV is known. Okay, remember that IV is always sent along the data that is to be transmitted. Okay, CRC is used for generation of ICV. Now CRC is a very weak in nature because of its linear property with respect to XOR operation. Linear means what? CRC of individual packets is equal to CRC of combination of packets. So if you want to know plain text from an encrypted packet, uh, take out carry out a CRC of ciphertext will give you ICV. Okay, so that becomes easy to, that's the same thing happened in case of authentication also. Since XOR operation is linear in nature, it is easy to find out the keys using the XOR operation. Okay, the weak RC4 keys for some seed values, that is called as a weak keys, the beginning of RC4 output is not really random. So pseudo random number generator generates a key sequence which was supposed to be random, but it is a accepting a input as a seed value, so which is not always random, and that makes a weak key sequence. If weak keys are used, then first few bytes of the output reveals lot of information about the key. So because of this repetition of input pattern, the breaking of the key is made easier. So that is the flaws regarding the encryption and integrity. And regarding integrity, because of CRC, integrity is weak, and because of weak RC4 key, encryption is weak. Okay, so although they provide certain side type of security, it is not really good security that one can expect from the wireless LAN. But nonetheless, compared to the open access wireless LAN, this is some sort of security that is provided by 802.11b. So to overcome these vulnerabilities, 802.11 came with a modified standard called as a Wi-Fi protected access that we will see in the next session. That's all for today. Thank you.